This is the Quadrilaterals in-class review. So this is our main study guide for the Unit 4 first quiz or first part of the test, however we want to call it. So it's going to be between about 30 and 35 summative points. So bigger than a quiz, smaller than a test, but a significant amount of points. This is the main study guide we want to focus on. I posted the videos for the optional study guide. Those were posted on the blog for Tuesday, December 18th. If you want to see those, but again, those are optional, not graded. This one is the class review that we are turning in. If you haven't already turned it in. So in the diagram below, we have a parallelogram ABCD with diagonals AC and BD. The measure of angle 1 is 37, and the measure of angle DCB is 120. So we want to start off by looking at the measure of angle DCB is 120. So we need to first find the measure of angle ADC. We know in a parallelogram, one of the properties of a parallelogram is that the consecutive angles are supplementary. So we have 180 minus 120. It's going to give us 60. So we know the measure of angle ADC is 60 because these are supplementary angles. Okay. The question's telling us that the measure of angle 1 is 37. Now we need to find the measure of angle 2. So these two angles, just the angle addition postulate, right? These two angles are going to add up to 60. So if we subtract 37 from 60, we get 23. So the measure of angle 2 is going to be 23. This is choice 2. 23 plus 37 gives us 60. And we have to have 60 here because we need these to add up to 180. Because they're consecutive angles, and consecutive angles are congruent. Number 2. The diagram below shows isosceles trapezoid ABCD with AB parallel to DC. So we'll put the arrows in to signify that they're parallel. And AD is congruent to BC. Legs in an isosceles trapezoid are congruent. If AD is 4x and BC is 3x plus 5, what is the value of x? What is the length of BC? So we know the legs in an isosceles triangle are congruent, and they tell us they're congruent. So 4x is going to equal 3x plus 5. If we subtract 3x from both sides, we have x equals 5. Okay, don't resist the temptation to go quick and move on. We have to solve what the question is asking for. This question is asking, what is the value of x? What is the length of BC? So we know BC equaled 3x plus 5. So we know BC is going to equal 3 times 5 plus 5. So BC is going to equal 15 plus 5, which means BC is going to equal 20. Make sure we are answering what the question is asking. So I don't have the most room here, so I'm going to kind of write these questions up in this space. So we can erase number 2. Number 3 here is asking us in rectangle ABCD. So let's draw a rectangle ABCD. ABCD. And again, when we name the rectangle, we have to go clockwise or counterclockwise. We cannot go diagonally. We cannot name this A, B, C, D. We cannot go diagonally. We have to go in order, clockwise or counterclockwise. So if you want to do A, B, C, D, that'd be fine. A, B, C, D, A, B, C, D, however you want to do it, as long as you are going in order and you're going clockwise. So going order in terms of the letters and going clockwise or counterclockwise. Don't go diagonally across. Okay. The length of AC is 6b minus 2. So 6b minus 2 is the whole thing AC. And then the length of diagonal BD is 4b plus 2. So that's the whole thing. Well, it's a rectangle. We know in rectangles, the diagonals are congruent. So since the diagonals are congruent, we can set them equal to each other. So 6b minus 2 is going to equal 4b plus 2. Subtract 4b. We get 2b minus 2 equals 2. Add 2 to both sides. 2b is going to equal 4. Divide by 2. We get b equals 2. You can resist the temptation to quit or to move to the next one until you read what you're trying to solve for. Probably should have done that before we solved it. Find b, check, we're good. The length of AC, okay, we got to substitute it back in. Well, AC is represented by 6b minus 2. That's a terrible C. AC equals 6b minus 2. We found b was 2. So AC is going to equal 6 times 2 minus 2, which is going to be 12 minus 2. So AC is going to equal 10. So now we have the length of AC. We're good to go. Number 4. In rectangle ABCD, the diagonals intersect at point E. The length of AE is represented as 3b plus 1. The length of DE is represented as 4 times quantity 2b minus 6. Find the value of BAC and BAC and BD. Okay. So again, we're going to do it up here. So let me erase. This was number 3. Erase this and this. So ABCD, the diagonals intersect at point E. So we're going to make this point E. Let's talk about what's going on first. So we know a rectangle is a parallelogram, and we know in parallelograms the diagonals bisect each other. So we know AE is congruent to EC, and we know BE is congruent to ED. In a rectangle, one of the properties we know is that the diagonals are congruent. So since the diagonals are congruent, meaning BD is congruent to AC, as we saw in number 3, and the diagonals bisect each other, we know that all 4 of these segments are going to be congruent. BE, EC, ED, and EA are all going to be congruent. The question is telling us that AE is 3b plus 1, and DE is 4 times the quantity 2b minus 6. So we know those 2 segments are going to be congruent, so they're going to be equal. Again, because the diagonals are congruent and the diagonals bisect each other, each of those segments there are AE, BE, CE, and DE are all going to be the same. So we have 3b plus 1 equals 4 times quantity 2b minus 6. So 3b plus 1 equals, distribute, we're going to get 8b minus 24. If we subtract 3b from both sides, we get 1 equals 5b minus 24. Add 24 to both sides, 25 equals 5b. Divide by 5, 5 equals b. Go back and look and see what we have to solve for. So we have to find the value of b. We got that. That was 5. Now we need to find AC and BD. So don't just substitute back into what we have. We have to solve for what they're asking for. So the first thing they're asking for after B is AC. So let's find AE first. Then we can figure out what this one is because these are the same. And then we can add them together to find AC. So AE is 3b plus 1. So that's 3 times 5 plus 1. So that's 15 plus 1. So that's 16. So we know this is 16. Meaning we also know EC is going to be 16. So to find AC, which is the entire diagonal, We have to do 16 plus 16, which gives us 32. So we know AC is going to equal 32. We also know BD is going to be 32 because the diagonals are congruent, therefore their lengths are going to be equal. So since AC is 32 and AC is congruent to BD, we know BD is going to equal 32. We can just double check that. Substitute in our B in here. 2 times B is 10. 10 minus 6 is 4. 4 times 4 is 16. If this is 16, this one's also 16. 16 plus 16 is 32. And I'm also going to do number 5 up there as well. So those were the two rectangles. I'm going to erase now, and now we're going to have number 5, which is a rhombus. So 3 and 4 are rectangles. We know diagonals are congruent in a rectangle. We also know they bisect each other because it's a parallelogram. So let's have a rhombus ABCD. So a rhombus is defined as having 4 congruent sides. So I'm just going to put the marks in so we know we have a rhombus. The diagonals intersect at point E. So let's put our points in. So A, B, C, D. Again, it doesn't matter where you start, but you have to go in order and you have to go clockwise or counterclockwise. You cannot skip across diagonally. You cannot say A, B, C, D. Our diagonals here are going to be AC and B, D. So AC is the diagonal and B, D. Oh no, I was reading the other one. We don't need to put diagonals in, but that's fine. The length in inches of AB is 3x plus 2. BC is x plus 12. Find the number of inches of the length of DC. Well, we know all the sides of a rhombus are congruent, so we know their lengths are going to be equal. So 3x plus 2 is going to equal x plus 12. Subtract x. 2x plus 2 is going to equal 12. Subtract 2 from both sides. 2x is going to equal 10. Divide by 2, we get x equals 5. Let's substitute that back in. 5 plus 12 is 17. This should also be 17. 3 times 5 is 15, plus 2 is 17, which means our other two sides are going to be 17 as well. So CD, DC, is going to equal 17 for number 5. Inches. 17 inches. 17 inches. 6 through 12 looks like we're going to do it all in the same spot on this one, just for the sake of room. So some of these equations might get a little longer, messier. Number 6, we have, how are we doing on time? 13 minutes for 5. That's fine. In the following diagram, we have an isosceles trapezoid, A, B, C, D. So I'm just going to put the legs in, because I know in an isosceles trapezoid, the legs are congruent. So I'm just going to mark AB congruent to CD. We know the measure of angle A is 46. Find the measure of all the remaining angles. Okay, well, we know in all trapezoids that the consecutive angles between the bases are congruent. So if these are our legs, BC is going to be parallel to AD. So this is going to be a base. This is going to be a base. AD and BC are bases. We know in all trapezoids, trapezoids being quadrilaterals with one pair of parallel sides, exactly one pair of parallel sides, the consecutive angles between the bases are supplementary. In addition to that, with isosceles trapezoids, we know the base angles are congruent. So those are the two angle properties we're going to be looking at. So if we know that the consecutive angles between the bases, meaning angle B and angle A, Could also mean angle C and angle D. We know they're supplementary. Consecutive angles between the bases are supplementary, so that means they're going to add up to 180. So 180 minus 46 is going to give us 134. So we know the measure of angle B is 134. Well, this is 46. It's telling us. Then the other property we know with isosceles trapezoids is that the base angles are congruent. So here's a base angle, so this is going to be 46. The two angles on the base angles. Then we know angle C is going to be 130. And again, consecutive angles between the bases are supplementary, so 134 and 46 is 180. Yep, that's all I want for 6. Good. We'll go to 7. Given the parallelogram ABCD, diagonals AC and BD intersect at point E, find the length of AE. If the length of AE is represented as 11x minus 3, and the length of BE is represented as 12 minus 4x, then what is the measure of AC? So we have a parallelogram A, B, C, D. Just don't go diagonally. Clockwise around or counterclockwise around. The diagonals AC and BD intersect at point E in our parallelogram. We know diagonals in a parallelogram bisect each other. So AE is congruent to EC, and ED is congruent to EE. If the length of AE is represented as 11x minus 3, and the length of BE is represented as 12 minus 4x, then what is the measure of AC? If the length of AE is represented as 11x minus 3, the length of BE is represented as, what is the length of AC? Are they not giving us enough information on this? So we know diagonals bisect each other. So we know EC is 11x minus 3. Don't see how they're giving us enough information here. Given parallelogram ABCD, diagonals AC and BD intersect at point E. If the length of AE is represented as in a parallelogram as opposed to in a rectangle, find the measure of AC. The diagonals don't bisect each other, so we don't have a right triangle. I mean, they're not perpendicular unless it's a rhombus. So we don't have a right triangle. I don't think we have enough information to solve this problem. BE, AE, it means CE? They gotta mean CE, right? Yeah, this has to be CE. This has to be CE. Let's do the problem as though it was CE. So let's say CE is 12 minus 4x. Sorry guys, I didn't catch that. So we know the diagonals are bisect each other. So we know these AE is congruent to EC. So 11x minus 3 is going to equal 12 minus 4x. Subtract 11x. Wait, what? Subtract, let's add 4x. We get 15x minus 3 is 12. Add 3, 15x. Divide by 15, and we get x equals 1. So the measure of AC, we have to substitute back in. So 11 times 1 is 11. 11 minus 3 is 8. And then we have 4 times 1 is 4. 12 minus 4 is 8. So AE equals 8. EC equals 8. So AC is going to equal 16. Yeah, there's no way we could have done this. The only way is if we had a right angle, then we could use the Pythagorean theorem to find AB. Yeah, that has to be CE. It's got to be CE. Let's go to number 8. There's a long pause there. That's fine. I'll one day figure out how to edit videos, but until then, we'll have to deal with that. Or maybe there is a way, and I'm just lacking the necessary knowledge. Okay, number 8 in parallelogram, A, B, C, D. So let's make a parallelogram. A, B, C, D. The measure of angle A exceeds the measure of angle B by 28 degrees. Find the degree measure of angle A and B. So angle A exceeds the measure of angle B by 28 degrees. So if we say angle B was 28, we say angle B was X, the measure of angle B was X. We're saying the measure of angle A exceeds the measure of angle B by 28, meaning it exceeds, it means it's more than. So 28 more than the measure of angle B. The measure of angle A is 28 more than the measure of angle B, so we're going to have X plus 28. We could also make angle A X, and then the measure of angle B would be X minus 28. Okay. Either way is fine. Find the measure of angle A and angle B. So we got to find X first. Well, what do we know about the consecutive angles in a parallelogram? We know they're supplementary. So X plus 28 is going to equal 180. 2X plus 28 is 180. Subtract 28. 2x is going to equal 152. Divide by 2, x is going to be 76. So we know this angle, the measure of angle B, is 76. Then we have to do 76. The measure of angle A equals 76 plus 28. The measure of angle A is going to equal 84 plus 20, which is going to be 104. That's number 8. All right. Number 9, we have square RSTU. Square RSTU. Square RSTU. In the square, we know we have 4 right angles. And because it's a rectangle, square is a rectangle. We also know a square is a rhombus, so it has 4 congruent sides. The measure of angle R equals 3x plus 33. What is the value of x? Okay, well, we know the measure of angle R is 90. And this is saying it's 3x plus 33, so we just set 3x plus 33 equal to 90. We know 3x plus 33 is going to be 90. Subtract 33 from both sides. 3x is going to equal 57. Divide by 3. X is going to equal 19. That one's pretty straightforward. Number 10, we have a parallelogram. Okay. 10, we have a parallelogram. So let's draw a parallelogram. A, B, C, D. One angle of a parallelogram is 12 less than 5 times the measure of the adjacent angle. So another word for adjacent is consecutive. So we could write consecutive angle. Consecutive. So instead of adjacent, we can put consecutive. That I don't even, just it's consecutive. Consecutive. So one angle of a parallelogram is 12 less than 5 times the measure of the adjacent angle. So one angle, let's just x. One angle of the parallelogram is x. Doesn't matter which one, we're just going to say one. One of them is x. So basically you have another one, the measure of the adjacent. So let's just say x is the adjacent angle. So one angle of the parallelogram is 12 less than 5 times the measure of the adjacent angle. So 5 times the measure of the adjacent angle is going to be 5x. And then we're saying it is 12 less than 5 times the measure. So 12 less means we're going to subtract 12. 12 less than 5 times the measure of the adjacent angle. So we've made the adjacent angle x. Okay, our angle is going to be 12 less than 5 times the measure of x. So 5 times the measure of x is 5x, and it's 12 less than 5 times the measure of x. So 5x minus 12. Now we need to find out what the measures of the angles are, which means we need to find x and then substitute it in. Well, we have adjacent angles, which is the same as consecutive angles. We know in parallelograms, we have a parallelogram. We know the consecutive angles are going to be supplementary, so they're going to add up to 180. So x plus 5x minus 12 is going to equal 180. That gives us 6x minus 12 is 180. Add 12 to both sides. 6x is 192, which is going to be 30 plus, it's going to be 32, I believe. X is going to be 32. So that's going to be 3, 192, right? 112, so it's going to be 32. Okay, so one of our angles is going to be 32. The other angle is going to be 5x minus 12, which is 5 times 32 minus 12. 5 times 32 is going to be 160. Minus 12, which is going to be 148. So 148 and 32 are the measures of our two adjacent consecutive angles. Number 11. What are we at? 29? Jeez. Okay, 29. Number 11. One side of a kite is 4 feet more than 3 times another side. The perimeter of the kite is 80 feet. What are the lengths of the 4 sides? So let's draw a kite. I'm terrible at drawing kites. So a kite we're defining as having 2 pairs of adjacent sides that are congruent, 2 pairs of consecutive sides that are congruent. One side of a kite is 4 feet more than 3 times the other side. Well, we know these 2 are congruent, we know these 2 are congruent. So if we're looking at 2 sides that are different lengths, we're looking at these 2 sides. So one side of a kite is 4 feet more than 3 times another side. So let's pick the another side. Let's call it x. Okay, and then we're going to find this one. So one side of the kite is 4 feet more than 3 times the other side. So 3 times the first side is 3x. So if it's saying it's 4 feet more than 3 times another side. So it's 4 feet more than 3 times the other side. 4 feet more than 3 times the other side. So if we make our original side x, then the other side, the one side of our kite, is going to be 4 feet more than 3 times the one other side, which we're just arbitrarily making x. If the perimeter of the kite is 80 feet, what are the lengths of the 4 sides? So we know these two sides are congruent. We know these 2 sides are congruent. So this is 3x plus 4. The perimeter is 80 feet. So the perimeter is the measurement of the outside. So we have 4 sides, so we need to add those 4 sides together. So we're going to have x plus 3x plus 4 plus 3x plus 4 equals the perimeter, which is 80 feet. Combine like terms, we are going to have 8x plus 8 equals 80. Subtract 8 from both sides. 8x is going to equal 72. Divide by 8. X is going to equal to 9. So our question wants the lengths of the 4 sides, not just x. So again, we have to read what they're asking for. So these sides are going to be 9 because x is 9. Okay, and then 3x plus 4, that's 3 times 9 plus 4, which is 27 plus 4, which is 31. So these sides are 31 and 31. 31 plus 31 is 62. 62 plus 9 is 71. 71 plus 9 is 80. Perimeter is 80, so we're good. So 4 more than 3 times. So 3 times the side is 27. 4 more than 3 times, 31. Given ABCD is a parallelogram, so this is number 12. Given that ABCD is a parallelogram, if 5x plus 9, AB is 5x plus 9, BC is 2x plus 5, CD is 2y plus 3, and AD is y minus 4. Find the value of x and y. So this is going to be one where we probably need more room to write, because this is where we're going to have to set our 2 equations up and then use substitution or elimination, preferably substitution. Try to maximize our space here. Draw a parallelogram here. A, B, C, and D. AB is 5x plus 9. BC is 2x plus 5. CD is 2y plus 3. And AD is y minus 4. So we have a parallelogram. We know the opposite sides of the parallelogram are congruent. So AB is congruent to CD, and BC is congruent to AD. So we know, since AB is congruent to CD, we know 5x plus 9 is going to equal 2y plus 3. We also know, since BC is congruent to AD, that 2x plus 5 is going to equal y minus 4. So we have 2 equations with 2 variables each. Normally, I like elimination better than substitution, but in this case, substitution is going to be easier. But you can do it either way. But I'm just going to do substitution because I think it's easier. I'm going to solve for this y. So I'm going to add 4 to both sides. And I'm going to get 2x plus 9 equals y. Then I'm going to substitute this in for y. So we're going to have 5x plus 9 equals 2 times 2x plus 9 plus 3. we're going to have 5x plus 9 equals, and we're going to distribute. So we're going to have 4x plus 18 plus 3. So 5x plus 9 is going to equal 4x plus 21. Subtract 4x from both sides. We're going to x plus 9 equals 21. Subtract 9 from both sides. We get x equals 12. How do we find y? We have to substitute x back in. We can substitute it into either equation. I'm going to sub it in here, though, because we already have y solved for. Okay, so I'm going to plug in x to here. So I'm going to get 2 times 12 plus 9 is y. That's 24 plus 9 equals y. That's 33 equals y. If we want to check our answer to make sure it's right, we can substitute all our x's and y's back into our original diagram to see if we have the correct answers here. 5 times 12 is 60. 60 plus 9 is 69. 2 times y, so 2 times 33 is 66. 66 plus 3 is 69. 2 times 12 is 24. 24 plus 5 is 29. Y is 33, so 33 minus 4 gives us 29. So we know opposite sides are equal, so we know we have the correct answer here. X is 12 and y is 33. I'm going to break this video up into 2 parts. So that is the end of the first page of the in-class review. I'm going to do the second part momentarily.